For C, we're trying to identify x coordinates of any extreme. So I want to find max or min points. So if you remember the definition of finding the max or min, we're going to take the derivative and set it equal to 0. So just like I explained in part A, because we're taking the derivative of an integral, they cancel each other out. So g prime of x is equal to f of x. So we're going to find the derivative, set it equal to 0. So we're trying to find when f of x is equal to 0. So we're looking at the graph of f of x. So f of x is equal to 0 at 0, 2, and 4. So we need to check those points. So at 2, the derivative is negative. Okay, so from 0 to 4, the derivative is negative. From 4 to 6, the derivative is positive. The reason I know this is because the derivative is equal to f of x, and we're looking at the graph of f of x. So notice that from 0 to 4, f of x is below the x-axis, so it's negative. From 4 to 6 is above the x-axis. So what that tells me is that at 1, it's neither a positive, it's neither a negative, it's neither a max or min, because I'm going from negative to negative. So my function g is just decreasing. At 4, I'm going from negative to positive, so I'm going to be going, g of x is going to go from decreasing to increasing, so that's going to be a minimum value. So I just have a minimum value. The next thing I have to do is I have to check at 0. And it's hard to check at 0 because it's an endpoint. So I'm going to go ahead and write the definition at 0. So g of 0 is going to equal from 2 to 0 of f of x dx. So I'm going from high to low, so I'm going to make that into a 0 and f of x dx. And notice that the area under the curve of f of x is underneath the x-axis. So this is going to be a negative number. And the negative times the negative would give me a positive. So g equals to 0, or at x equals to 0, is where my max occurs. Remember, this is not the actual max or min, we're just finding where it occurs. So x equals to 4 is where my min occurs, x equals to 0 is where my max occurs.